Today we're going to take a look at an example that involves smog in Los Angeles. So if you look at our chart here, on the left-hand column we have the year, and in the right-hand column we have the number of smog days over the national standard. Let's take a look at our problem. It says, use the data to find a linear model and use the model to predict the number of smog days in Los Angeles for 2011. Okay, it says find a linear model, and so whenever you hear the word linear, you want to think line. So what they're asking us for is to find the equation of a line. Let's go ahead and recall that the equation of a line is given by y equals mx plus b, where m is the slope and b is the y-intercept. So if we can find the slope and the y-intercept, then we'll have our equation. Let's take a look at our graph. On our graph, we have each of these points plotted, where on the horizontal axis, we have the x-axis, and on the y-axis here, we have the number of smog days. And so we can go ahead and define our variables. We'll let x equal the number of years since 2001. And we'll let y equal the number of smog days. Okay, we'd like to have a line that passes through the middle of all these points. We'd like to approximate this trend. And so if we choose 2 points, for example, these two, then our line will look like that. And that doesn't approximate the data very well. Let's go ahead and choose 2 other points. I'm going to choose this point and this point. And so if we draw a line through those 2 points, we have a line that passes through the center of that data, and so it approximates the trend pretty well. Now, this is an arbitrary choice. You might choose 2 other points, but we'll work with these 2 points right now. So these 2 points correspond to ordered pairs. It corresponds to this one here in 2001, and it corresponds to this one in 2009. We can go ahead and use those ordered pairs to calculate the slope of our line using the slope formula. So let's recall what the slope formula is. M equals y2 minus y1 over x2 minus x1. y2, that means the y coordinate of the second point, and so that's going to be 7. Minus y1, which is the y coordinate of the first point, that's going to be 53. Now in the denominator, we're going to have x2, which is the x coordinate of the second point. Now the x coordinate of the second point is 2009, but remember x is the number of years since 2001. So the number of years since 2001 in 2009 is 8 years. It's a difference of 8 years. Now we want to subtract x1. x1 is 2001, but remember that's the difference of years since 2001, and so that's a difference of 0. And so we end up with minus 46 over 8. Which is negative 5.75. So that's the slope of our line. And so we have part of the problem done. Let's go ahead and shrink that down and clear up a little space to work here. So I'm going to go ahead and shrink that. And we know that our slope is negative 5.75. So now we need to find the y-intercept. We have the slope. If we can find the y-intercept, then we'll have our equation. Now, the y-intercept we find the same way we always do, by letting x equal 0. So if x is equal to 0, that means the number of years since 2001 is 0. And so that's going to correspond to our first ordered pair right here. Okay? And so the number of smog days in 2001 was 53. And so when x is equal to 0, y is equal to 53. So now that we have the y-intercept, we can go ahead and write the equation of our line. Y equals negative 5.75x plus 53. Okay, so that's the equation of our line, and that's our linear model. Now we can use that equation to answer the second part of the question. So the second part of the question says, use the model to predict the number of smog days in Los Angeles for 2011. Okay, so let's go ahead and shrink this, and that'll clear off a little space for us to work. We'll move this down here like this. Okay. So we want to go ahead and use our model to predict the number of smog days in 2011. And so x which is the number of years since 2001, in 2011 will be 10. That's a difference of 10 years. And so we'll come over to our equation and substitute 10 for x. So we'll have negative 5.75 times 10 plus 53, which is going to equal negative 57.5 plus 53, which is equal to negative 4.5. Okay, and so we have a negative number, and so what does that mean in the context of our example? Remember, y is the number of Smaug days over the national standard, and so if we have a negative number, that means in 2011 we will be under the national standard by negative 4.5 days. And so that's the predicted value for the year 2011.